Hi! Angular 20.1 extends the brand new binding API to testing, introducing a modern, clear and reliable way to test component inputs, outputs and two-way data bindings. This video, however, goes beyond just demonstrating the new API, because I wanted to show you also the older approaches and compare them side by side so that you clearly see the benefits of the new features. And since a lot of people are actually struggling with unit testing in Angular, I tried to be very detailed in my explanation, and that's why this video became slightly longer than I expected. But I added a very detailed timecodes to this video, so you can jump straight to the part you are interested in. So, if you're ready, let's get started. Let's very quickly take a look at the component we are going to test. So this is the widget component that shows the current weather, not the real one, but still. And this component has a couple of inputs through which the component consumer can provide the widget title and description. This component also provides an output that emits an empty value when the user clicks the close button. Currently, the output handler just destroys the widget, but of course there could be any other logic. And also it has a less info button, clicking which we can collapse the widget information or expand it again. And what I especially wanted to highlight is that the collapsing state is synchronized with the checkbox right here. So whenever the state of the checkbox changes, it is reflected in the widget state and vice versa. Whenever the inner state of the widget changes, the checkbox is synchronized accordingly. And this is two-way data binding in action. Now let's take a look at the component implementation. As you can see, it is extremely simple. Here you can spot two component signal inputs, also the collapsed model input, which is responsible for two-way data binding, and also there is a closed property, which is an output that emits an event when user clicks the corresponding button. And here is the component template itself. As you can see, nothing fancy here, just a normal template with simple property and event bindings, which should be familiar even for every beginner in Angular. I've prepared a set of tests for this component, so let's switch to the corresponding spec file. They are written currently in the old-fashioned way, and we will explore them in a minute, but first, let's run our tests to make sure that everything works. You can run tests using simple ng test command in your terminal, but I will do it using a very cool VS Code extension called WallabyJS that you can actually install as well. And once you install it, you can activate a trial version, and after that you will be able to run commands like wallaby start, and tests will be executed and the report will be displayed right in the VS Code. And if a certain test fails, let's maybe break some of tests conditions right here. Yeah, right, you can see that I get immediately an error report about the broken test in my code editor, which is very convenient. It also offers a lot of other cool features, like a very convenient way to debug your tests. And besides that, it brings many other cool things that might improve your productivity as a developer. And if you enjoyed the trial and you would like to activate the full version, in the video description, you can find a special link that gives you a 20% discount for WallabyJS license. So check this out. But now let's continue and let's get started with component inputs testing. Alright, so prior to Angular 14.1, the only reliable and proper way to test component inputs was the test host pattern. The idea of this pattern is pretty straightforward. You just create a special wrapper component that imports the component you are going to test, and you declare it inside the wrapper template. Because I want to make sure that the title and description provided via corresponding inputs are correctly rendered in the template, I define the corresponding signals inside my wrapper and bind their values to the widget inputs accordingly. After that, I create an instance of the wrapper component, which eventually creates an instance of my app widget component as well. And right after that, I call detect changes to perform the initial change detection, which updates the widget component input bindings with the provided values. After that, I simply reference the DOM nodes in the widget component template where the corresponding title and description text have to be rendered, and I just make sure that the inner text of those DOM nodes is equal to what is provided through the corresponding inputs. So the text for the title should match the text of the corresponding signal that is bound to the title input. Though it requires some boilerplate and additional setup, this approach is great because it was the only way that guaranteed the input binding processing the same way how it happens in component template in real non-testing environment. It respects the input aliasing, it triggers proper lifecycle hooks when the input changes, and it also marks component template as dirty when the input value changes. And because of that, for a long time, this pattern was the only proper way to test components with on-push change detection strategy enabled. However, things got better starting from Angular 14.1 when the setInput method was released and became available inside the componentRef property. Thanks to this method, we can avoid the wrapper component in most cases, and we can create the component we are going to test directly. Then we can simply set up component input values and it works just fine, because the set input also respects the input aliasing. It marks the component template as dirty when we change the value of the input, and also it properly triggers the ngOnChanges lifecycle hook. However, the underlying mechanics were still a bit different from what happens in the component template, though it's very close to it. If you are curious why it is so important to be as close as possible to the real behaviors, I have a great example for you that I will show you later in the section dedicated to component output testings, so please continue watching. Anyway, in Angular 20.1, we've got an opportunity to get the best from both worlds. The simplicity of the set input approach and the reliability of the approach that utilizes the component wrapper. This is possible due to the brand new binding API that was initially released in Angular 24 dynamic components, and I already covered it in the separate video. But now it was rolled out to Angular testing, so let's take a look how it looks in action. So you have to create a component that you are going to test using the testbed create component method, as you would usually do. But since Angular 20.1, you can provide a second argument for this method, and this is an object where you can define an array of bindings, which works the same way as the bindings I already described in the video I mentioned. So let's just create a corresponding input binding for the title input, which looks like this. So here we go. And I'm going to do the same for the description input as well. And again, defining an input value as a function makes the input static, which is okay in my case. But if your test scenario requires an input change later in the test case, you can create a dedicated signal that you can provide as a value for the input binding as well. And then later, whenever you want to change the input value, you change the value of that signal, and this is it. Everything will be picked up and updated accordingly. After that, again, we have to perform the initial change detection to update binding values and perform the same check we did in our previous test. So I can actually go and copy this part from one of the previous test case, and then I just simply go back to my newly created test case and paste this part right here. So here we go. And as you can see, the test passed successfully, and Wallaby tells me that everything is all right. And of course, some of you might point out, like, Dmitro, you do a lot of copy pasting. Didn't you hear about it before each hook, etc., etc.? I know that. I just want to keep everything on one screen so that you don't lose the context. And this video is not about the test organizing, but I will create a separate video that will be available for patrons and for the YouTube channel members, where I will show how I would organize my tests with this new API. But anyway, we are done with the component input testing, so let's quickly highlight what benefits brings this new approach. First, we don't need a wrapper component anymore. Secondly, input binding assures that input binding changes in our tests will be processed the same way how it happens in the component templates. And third benefit is that our test code is still lean and clean, like with set input approach. And now let's move to the component output testing. So here I've prepared a few variants of tests for component outputs. And again, the one uses the test host pattern and another doesn't. Those are not only ways to test component outputs, but I've chosen those two because they are the most popular in my opinion. So let's get started with the test case that uses the test host pattern. And the idea is again the same. So we create a wrapper component where we define the following use case, namely when the widget emits the closed output event, we simply update the isClosed signal property of the wrapper component and set it to true. That's it. Then in my test, I create an instance of the wrapper component and I immediately validate if the value of the isClosed signal has the default value. After that, I get a reference to my close button in the widget template and I simulate a user click on this button element. Once it is done, I validate that the value of the isClosed signal is true, which verifies that the output has been indeed fired and the subsequent logic is executed. And again, likewise with component input testings, up until now, the tests using the component wrapper pattern, it was the most reliable way to test component outputs as well. And the reason is the same. The behavior is the same as in the component templates in non-testing environment. However, there are of course more lightweight alternatives, so let me show you the one. Here we create a testing component directly and start spying on the emit method of our closed event emitter. Once the click event is fired, I expect that emit method to be called with an empty parameter, which is exactly what I need actually, because in my case the closed output emits void. Though this test is still pretty reliable, it doesn't involve the entire output emission process, which might sometimes lead to false positive or false negative results. And here's an example I promised you to show earlier. So imagine you work on a huge project and one day one of your colleagues you don't even know vibe coded a function with the same output name and maybe even a similar interface that has also emit method. By mistake, you relied on your editor, which automatically imported this new function instead of the one that comes from Angular core. So eventually you use the wrong output function in your component. Looks legit, right? No compilation errors, nothing. But maybe our test could catch this mistake. But no, our test is still green, and this is because this test doesn't test that the output has been actually emitted. It just checks that a certain method has been called. In contrast, the test that utilizes the test host pattern could successfully catch this mistake and properly report the wrong logic, because again, here we test if the output is actually emitted, all right? And this is why it is so important to be as close as possible to the real behaviors in your tests. Okay, so let's revert the change I made previously in the widget component file, and let's go back and see how we can use the new binding API to simplify our test, keeping this still reliable. So again, you start as you usually would do by creating a component you want to test. Then you provide a configuration object, and there inside you define the bindings array as usual, but this time you create the output binding that is going to be attached to the closed output. Here you have multiple options. You could use a tactic we used inside the test case with the wrapper component. So we could have a certain signal like expected output that will be updated when the closed event is emitted. Then we would again get a reference to the close button and simulate a click on this button element, and we would then expect that the value of the expected output signal is true. Alternatively, you could use the approach with the spy. This is how it would look like. I don't see any significant difference, to be honest, especially in my case. In general, I would say that the variant with spy could be maybe more flexible in some cases, especially if you need to count how many times the output value has been emitted. But anyway, usually it's just a matter of taste. Now, let's very quickly highlight the benefits of this new binding API. So again, no need an additional wrapper. The output binding ensures that everything behaves in your tests the same way how it would happen in non-testing environment. And third, it is still lean and clean and also aligned with the inputBinding API. And the next chapter is the two-way data binding testing. Up until now, in my opinion, the only reliable way to test two-way data binding in our components, it was using the test host pattern. And this is how I set up it in my case. So I defined the two-way data binding in the template for the widget's collapsed property, and I link it with the isCollapsed signal. So the idea is that whenever the collapsed property inside the widget component changes, the value of the isCollapsed signal should be synchronized with this change as well, and vice versa. And now let's take a look at the implementation of the test case that tests the behavior I mentioned. So what I do here is create a wrapper component. Then I assign the wrapper component class instance to a wrapper constant. I also query the instance of the widget component and save the corresponding widget class instance to the widget constant. And then I perform the testing logic in 2 steps. The step 1 tests the synchronization, let's name it from bottom to top. So what I mean by that is that when the widget's collapsed property value changes, then this value should be synchronized with the isCollapsed signal, which is a property of our test wrapper component, and vice versa. If the value of the isCollapsed signal inside the test wrapper changes, then I expect that the value of the collapsed signal inside the widget's class instance it will be also synchronized and will get the value false as well. I hope you've got the idea. And now let's take a look how it would look like when we apply the twoWayBinding API. Let's create a separate test case somewhere here. And again, I continue as I would usually do by creating the widget component itself. Then we provide the object with the bindings array, where this time we define the two-way binding, and I'm going to apply it for the collapsed property. And then as a value, we should provide the signal that has to be, let's say, linked with the value of the collapsed property. So let's create it somewhere above and add it as a second parameter for the twoWayBinding function. And then you continue in pretty much the same manner as in the previous test case. So you simply change the value of the collapsed signal, and then after you detect changes, you compare that the value of the isCollapsed signal is synchronized and also has a value true. And then you test another direction. If the value of the isCollapsed signal changes to something like false, and if the twoWayBinding works properly, then the collapsed signal inside the widget component class instance should be synchronized and get the value false as well. And this is how you would test the twoWayBinding with the new twoWayBinding API. If you have problems with understanding the twoWayBinding concept, I have a dedicated video where I explain everything in details, so you can check it out right now. But anyway, let's quickly recap all the benefits of using this new API, and they're pretty much the same. No wrapper component is needed, behaves the same way as in normal component templates in non-testing environment, and again, it is lean, clean, and aligned with the rest of binding APIs. Alright guys, thanks for watching, and if you want, you can check my other videos about unit testing in Angular if you want to continue exploring this pretty interesting topic, or if you want to learn unit testing in depth but don't know where to start, I've created an entire video course about it. Links will be in the video description. You can check it out and enroll if you want. Otherwise, please share this video with your colleagues and friends if you find this video useful, and join our free Angular community on Discord. We are already thousands of developers around the world discussing about Angular, learning together, and we are looking forward to meet you as well. And thank you everyone who supports my channel on Patreon or here on YouTube. I wish you all the best guys, stay safe, and see you in the next video.